Alright, so this is gonna be actually part 2. I thought about doing like 1.7 or something like that, but I'm just roping this in with part 2. So, just some major / minor updates to the panel. So the first thing we have is the piezo is gone. I also figured out that pin 0 can be used as a digital output. So that's pretty cool. So you can see we now have 4 relay spots. So 2 are, what we had before, horn and strobe. 1 is actually for speakers, so it's going to be connected to like an MP3 board. And then this one's resettable power, so that's why it's on right now. And when you reset it, it switches off for 5 seconds and turns back on. Now, another thing that I've done is I actually figured out how to do zone supervision, and in doing that, I pretty much made resettable power supervision. So basically, these switches here are symbolizing a break in the zone. So if I create a break, we got a fault. I also changed P to F because somebody, specifically NES Man, probably seen him on YouTube, he told me that problem doesn't make sense and fault would be much better. So as you can see, it goes out of fault, works on all 3 of these. And yeah, now the only problem with this that I can't fix, but oh well, is the trouble clears when the pull station's pulled while it's verifying the alarm, which is fine. And so yeah, another thing is if we go to the sync page, we got, this one, which is basically just a very simple, like, I call it clicks, basically. The relay's turned off for 1/10 of a second every click. So it's basically 1 click per second. That's what this is. And you already knew that was there. This actually codes the strobes to march time for light blades. And now we have 4. Now to show you what 4 is, it's actually pretty cool. This is actually Wheelock sync. So it's clicking the relay. The simulation sometimes doesn't pick up the clicks because they're super short, but they are happening. And yeah, it took me a really long time to figure out how the sync protocol worked, but I finally did, and I'm glad I did because it's really nice. Now if I click silence, it actually changes the protocol to the audible silence protocol. And some of the clicks, as I said, are not picked up by the simulation, which I can't fix. Now, another thing I did is for, I think it's 8, the one that basically makes everything be quiet when you pull it, it actually automatically puts it on silence. So if I pull the alarm when it's on this, we also got a fault because it's, not normal operation, the horns aren't going to sound. We're immediately in the silent sync protocol and the silence LED's on. So you can probably tell I organized the pins much better. And I also switched the poles that were being read on digital pins, they're now being read on analog pins, which allows me to detect exactly how much voltage is going through it, which is how the supervision works. And I also, I'm just turning this so that we don't have a fault, I organized all the colors better. So basically when I go to plug all this in real life, I can not separate all the cables, and I can actually have ribbons running to different things. So like I could probably have one ribbon consisting of both yellow and green, which is the lighting, and then these buttons could all be on a ribbon here. So yeah, it'll make a much cleaner look and easier to maintain wiring that doesn't look very bad. So yeah, that's pretty much it. Now moving on to the next part of the video is going to be sourcing all the parts to build this. Okay, so these are all the parts. I'm not going to scroll up because it shows personal information, but these are actually in the mail currently. So we got the 7-signal display, we got 3, these are smaller breadboards because the big ones are out of stock, so I got 3 of those. I got 40 ways male to female wires, and then 40 male to males. 10 of each color LED, since they're literally like 3 cents each. I got this 9-volt battery connector, which will be connected to the Arduino to give it power, and through the 24-volt to 5-volt step-down transformer. We got an Arduino Mega, and the reason I did a Mega instead of an Uno is the Uno went out of stock the day before I ordered everything, so I had to scramble to find a cheap one, and it was only like $6 more. We got 4 relays in the form of 2-channel boards, 3 push buttons. These are actually really nice buttons. I got 5 little green terminal blocks that allow me to, like, you know, basically have terminals to connect my zone wires to. And 30 resistors. Yeah, basically. Now I'll show you these buttons. These are actually really nice. And they were pretty cheap. As you can see, they're like, you know, nice looking buttons. I don't know for sure how I'm gonna connect these pins here, but I'll figure it out. So yeah, it looks really nice. So that's pretty much it. This is Citron Marketplace is where I got all this stuff from, and it's really nice if you need to do any Arduino projects, because you can search, for example, you know, LED, and you get lots of different options. You can get 5mm LEDs, you can get 3mm LEDs. I got 5mm because I think they're more voltage too, so I kind of needed to. And you can get resistors, breadboards, lots of cool stuff. So yeah, that's pretty much it for the part sourcing. I actually also got a few things from eBay, which I will show up on the screen now in images. So one thing, I got a Pyrotronix Pad 2 cabinet. The reason I got that is that's the only thing the seller had, and I got a good deal for it. So yeah, the Pad 2 cabinet is really nice. It has a lock. It's black. I think it's 15 by 12 inches, which is really nice. And another part that I'm going to need from eBay is the transformer that converts 24 volt to 5 volts. Which, yeah, because the board actually runs on 5 volts DC and the alarms will be running on 24 volts. That's pretty much it for part 2. Part 3 will be, you know, building everything. This is actually pretty short. I thought it would be longer, but here we are. So, thank you for watching.